Welcome back again. Now we are looking at a series circuit. We just want to have a look at what are the characteristics of a series circuit and how does it compare with a parallel circuit. In a series circuit, you can see that from the battery, which is the source, we've got a fuse and then we've got a switch, and then we've got lamp 1, lamp 2, and lamp 3 all connected in series such that the current has only got one path. From the source, it will pass through the first lamp, lamp 2, and lamp 3 back to the source. So it means there's only one passage for current. Now, what are the characteristics of a series circuit? You might find that the current which is passing through all the loads is the same in a series circuit. It means the current from the source through the loads back to the source will remain the same. But the voltage drops. It means each load, each consumer we've got there, like lamp 1, will get part of the voltage which is coming from the source, and lamp 2 will also get part of the voltage, and lamp 3 will get part of the voltage. Now, if all these lamps were rated the same, it means we just have to divide the 12 volts divide by 3 because the lamps are rated the same. It means each lamp will consume 4 volts. That's about all. So it means the voltage drop across this one, if after voltage passes through this lamp 1, the voltage remaining here will be 12 minus 4. It will be 8 volts remaining here. So if we were to put a voltmeter on there, you will find that on here you are going to get a difference of 4 volts is going to be consumed, another 4 volts consumed there, another 4 volts there. If we try to measure here, we are going to get 0. So it means all the voltage will be consumed by the loads in there. But the current will remain the same. The current at source, the current there, the current there, the current there will remain the same. Those are the major characteristics of the series circuit. Another thing which is prominent about it is the resistances. These, because it's a load, it means it will have some resistance. Equally, this will have some resistance and this will have some resistance. So it means the total resistance in a series circuit is cumulative resistance, which we call equivalent resistance. So it means we add the resistance, this R1, R2, R3, we add them up to give us the final resistance. What we are saying is I, current, same through the load, voltage drop, it means the way we term voltage drop at which is IR1 plus IR2 plus IR3 should be equal to the source voltage. So it means the additive of all the voltages, the voltage drops in all these will add up to there. And then R, which is the resistance, is equal to R1 from lamp 1 plus R2 from lamp 3 plus R3. So that's the total resistance in that circuit. Those are the major characteristics about a series circuit. Like we are saying here, to prove just what we've been talking about, what we will do is an actual circuit, wire up a circuit and put up the 12 volts and put up the 3 lamps. And then we'll measure the voltage drop across each lamp and measure the current which is passing before lamp 1, before lamp 2, before lamp 3, and after lamp 3. And then we'll see if it's going to be, like the theory we are saying there, and the voltage drops, if it's going to be equal to the source voltage. And then the resistance, if this is going to add up, because all we can do is, because we haven't done Ohm's law, so it won't go into those details. But we'll do this experiment and to show just what we have been trying to say is true.